It's going to be similar to the other day when we did areas of parallelograms and triangles. Now we're dealing with trapezoids, rhombi, right, plural for rhombus, and kites. So you've used area formulas for trapezoids before, but you're always usually given the information. And just like you noticed with our triangles and our parallelograms the other day, you had to use, maybe like a trig ratio or your special right triangle or the Pythagorean theorem or something like that. You had kind of problem solve, look back at some past knowledge to be able to get all the things that you need to solve. So not only do you need the formula, but you need to remember back on how to find some different information depending on what you're given. So in this case, area of a trapezoid, quick review for you. It's kind of like your triangle, 1/2 base times height, except now you got two bases that you have to add up before you can apply the formula. So here's the formula. Area equals 1/2 times the height times the bases added together. I like to think of it as the triangle in the way, like 1/2 times base times height, except I got two bases. So I just add the bases together first, and then I kind of apply the formula. Or, add the bases times the height and then divide by 2. A lot of different ways to do it. Whichever most comfortable, but you just got to apply the formula like it is. So let's just try one, and we'll come back to that. So it says, Miguel designed a deck shaped like the trapezoid shown below. Find the area of the deck. Well, I'm going to go ahead and I'm going to write my area formula down. I like to see it. So 1/2 times the bases added together, base 1 plus base 2 times the height. Okay, it doesn't matter if you have the h before or after the two bases there. Well, what do I know so far? I got one of the bases, 9 feet, and I got the height of 4 feet. So I just need the other base up here. So how could I solve for that guy? Oh boy. Let's think of some things here. I'm not giving any angle measures, so I doubt I'm using any trig ratios. Well, let's see. Kind of tough. Well, maybe you need to draw in another line. So, for example, could I break up this trapezoid? Like if I broke it up into a rectangle and a triangle right here. Does that help me? Because do I know this height? Sure, it's 4 feet. What do I notice? I just made a right triangle, and I know two of the sides, 5 feet and 4 feet. So I could use the Pythagorean theorem, right? A squared plus b squared equals c squared, where the hypotenuse is my c. So I could solve for this piece right here. Well, this is also a Pythagorean triple, a 3, 4, 5 Pythagorean triple. So if you remember, it's nice and easy. I know this is going to be 3 feet here. Otherwise, I'd have to go through and say, if I called this guy x, I could say x squared plus 4 squared equals 25 squared, or 5 squared, which is 25, my fault. And we'd get 16 and 25 when we subtract the 16, and that's where that 9 comes in. So there we go. I was right, it was 3, because it's Pythagorean triple. Well, how does that help us? Well, if that's 3, and this entire piece is 9, that means this part of it has to be 9 minus 3, which is 6 feet. So there we go. Now I solved for my other base. So what I have to do is apply my formula, my trapezoid formula, and so we have area equals 1/2, add my bases, so 6 plus 9, I'll write them out this time here, and then times the height of 4. So we'll simplify here. So this guy becomes 15, and I'm going to do the half and the 4 together, so half of 4 is 2, so 2 times 15 gives us 30, and we need a correct label. It's feet, and we're talking area, so feet squared. There we go. Just got to look closely and problem solve a little bit and figure out what you need to do. Oh, now we got to go back. The nice part about rhombis and kites, or not rhombis, rhombi and kites, is that they have the exact same formula. You take 1/2 times one diagonal times the other diagonal. And remember, a diagonal is just that it's going like crossways through the kite or the rhombus. So for example, in this rhombus here, diagonal 1 or diagonal 2 times diagonal 1 and half of that. In this kite, diagonal 1 times diagonal 2 and half of that. Okay, that's all there is to it. So it has nothing to do with like the side lengths of it. You're dealing with the diagonals now whenever you have a rhombus or a kite. So let's go apply it. So find the area of each rhombus or kite. So I'm going to write my formula. Area equals 1/2 times one diagonal times the other diagonal. Diagonal 1 and diagonal 2. That's what those little numbers in the bottom down there mean. Well, here we go. I got a kite. So I apply my formula. Area equals 1/2 times one of the diagonals, which is right here, and that's 12, times the other diagonal, which is right here, which is 7. Right? Pretty straightforward. And half of 12 is 6, and 6 times 7 gives us 42, and we're in feet, and it's area, so feet squared. Pretty straightforward there. Well, how about here? These years just don't work too fast, right? I got a rhombus now, and so it's still the same formula, 1/2 times the diagonals, diagonal 1 and diagonal 2. Well, if I think about this guy's 9 here, so this guy's also 9, which means the whole thing has to be 18, so there's one diagonal. So don't work too fast and take 1/2 times 9 times 7, because the diagonal is 18. And the horizontal diagonal would be this all the way across, so 7 and 7 for 14. And then I can simplify that a little bit, take half of 18 and get 9, and 9 times 14 gives me 126. And we're in inches, and it's area, so inches squared. So just don't work too fast and make a little mistake there. Okay, when it gets a little bit trickier is when it gives it in words and doesn't give you a picture. So right here it says one diagonal of a rhombus is half as long as the other diagonal. If the area of the rhombus is 64 square inches, what are the lengths of the diagonals? Okay. It gets kind of confusing if you just read through it. One thing that might help is drawing a picture. The other thing is, I look and I see area of a rhombus. I'm going to write down my formula. That's going to help me. Area equals 1/2 times first diagonal times the second diagonal. And then I'm going to decide, I'm going to write down the things I need to plug into this. I need to know the area, I need to know diagonal 1, and I need to know diagonal 2. Those are some information that I need. Well, what do we know? We know the area is 64 square inches. Okay? And I know that one diagonal is half as long as the other one. So if I call one of these diagonals x, the other one would be half of x, or 0.5x. So one diagonal is half of the other one. Bring a variable into play. Well, now I can plug in my information. So 64 is the area, equals 1/2 times diagonal 1, which is x, times diagonal 2, which is 1/2 x. And let's start simplifying some things here. And if I think about it on the right side, it's just 1/2 times x times 1/2 times x. It's all multiplication. All multiplication. So I can multiply anything I want in any order. So I'm going to multiply 1/2 times 1/2, which is 1/4. I'm going to multiply x times x, which is x squared. Well, we want to get our x by itself, our x squared by itself. So to get rid of that 1/4, we multiply by the reciprocal, which is 4 over 1, or times 4. Whatever I do to one side, I got to do to the other side. So that would cancel, and 4 times 64 gives us 256 equals x squared. And then to solve for x, we take the square root. So the square root of 256, and x would equal, what is that? It's one of our perfect squares, right? I believe that is 16. So x is 16. Well, if I look back over here, right here, 16 inches is the one diagonal. The other diagonal is half of that. So the other one must be 8 inches. And that's what it asks for. What are the lengths of the diagonals? So 16 inches and 8 inches. So basically just bring a variable into play and go through and solve. And that's all there is to it.